All right. So homework was to actually show some information on another page, show kind of a list view of stuff, right? So what stuff are we supposed to show? We're supposed to show name and phone number, just those two things. All right, so we already have some code up here that should give us, so at the end of class last time, we made this RESTful API call to Yelp. We made sure we put in the authorization header for this guy. We built in the location and category for restaurants. And this is going to pull in a big JSON string thingy that looks like this. Okay, and we were looking at that inside of Postman, right? So we can kind of see this is what our JSON string looks like in here. And we're pulling out the name of this guy. What we also want is the phone number. You could choose which one you want. I'm going to say maybe take the display phone. Display phone looks a little prettier, but you can choose whether you want a display phone or phone. So if we go back to the code here, I'm already pulling out the name. So I can now also pull out the string phone, and this is businesses dot, we'll get the JSON object from bucket I of the array. And then we're going to get the string in there, and that string is called display phone. So that should get me the phone number, right? Now, just so we can see walking through this, I'm going to go ahead and use the debugger. So I'll put a breakpoint right there. We will run this guy in the debugger real quick. So I'll click the little bug guy, and we'll just see it pop in there so we can see name and phone number with the correct value several times. Is it getting into the code? Let's just make sure it's getting in here. Make sure I'm not on the guest Wi-Fi either. Okay, so we're getting to the URL thing. We'll step over that, step over that, step over that. It's trying to get the input stream from that. Just make sure that this Yelp site is up. Actually, I should be able to just do Postman here. All right, we're able to get it there. File input stream, open. Yeah, let me just try closing Android Studio and relaunching it. It's not giving me my input stream, but the internet's working. Of course, there's an update. But why? I'll go ahead and click update while we're at it. Wonder if I can. I don't think I have a strong enough signal to give myself a hotspot. What I'll do here, as soon as this is done updating, I'll just run it normally, look for the prints for the name, just in case it's the debugger that's hanging up. I wonder why it is that Android Studio literally has updates daily. Just daily. You know, just, I don't know, it doesn't make any sense to me. Well, I mean, in general, I like the tool. But I mean, if they change stuff so often that it starts breaking other things.
It seems like it breaks all the time.
I mean, that's a big update. 1.9 gigs.
It's already downloaded. I don't think it was. I don't think it was all that. Oh, I see it. Oh, that's for Android 6. That's for the emulator. Well, here, while that's kicking, let's open up Keynote and we'll walk through and talk about the final. So we'll just do things a little bit backwards while that's updating. All right, so final exam is going to be 10:10 a.m. on Tuesday. So 10:10 a.m. Tuesday of next week. The exam will be the same length as the midterm. So it'll be 10 questions, probably 6 to 7 programming-ish, and then 3 to 4 short answer. Expect at least one conversion question. So that's either base to another base or size/speed to another size/speed. So megabits to gigabits or gigabytes to bits, or megabits per second, which would be a speed. Like if I ask something about an internet connection, so make sure you know that chart, the 1024 multipliers and then the 8 multiplier. We have 8 bits in 1 byte, so it takes a multiplier of 8 to jump between those two columns. And then it's 1024 multiplier on the way down to each of those columns. So know that chart, and then also be able to convert between any base between base 2 and base 36. All right, so there'll probably only be one of those, but I reserve the right to put 2 if I feel like it. Okay. You will have the whole 2 hours to take it. It should not be a time crunch thing. If you want the whole 2 hours, you have it, but I'll design it for what's usually an hour and 15-minute class. So you very well might finish it in 30 minutes or something like that. All right, so let's go back to so this was our midterm. So let's go post midterm. So we talked about stacks and queues. We also finished up this idea in linked lists where if you remove something from a linked list, its size is now altered, right? So if you have a loop that's going through a linked list and you change something in the linked list, this was represented on the midterm, right? And you change something on that list now has a new size. So if you used to be looking at bucket 7, and then you removed bucket 7, now you're still looking at bucket 7. What used to be bucket 8 is now bucket 7. That makes sense? Okay, so understand that with linked data structures, since they can dynamically grow and shrink, when you remove something from them, we now need to take into consideration any counters that we're using to index through them. All right, so understand the difference between stacks and queues. These are still linear linked data structures. A stack has the push pop peak. So you should be able to implement a simple stack. You should be able to solve problems with a stack. If I give you some code that shows a stack, and it has some code that manipulates a stack or something like that, you should be able to tell me what the result is. So make sure you speak the language of push pop and peak. Queues, kind of another special use of linked lists. We didn't really go into them in any sort of great detail, but we kind of understand that a queue is like a line in real life. You get into the end of the line, you get removed from the front of the line. So you NQ at the end of the line, you DQ, and get your snow cone or ice cream cones, DQ, right? So in any case, a stack is a last in, first out linked data structure, linear linked data structure, where a queue is a first in, first out. So when you get into the end of the line of McDonald's, you're going to be first come, first served in that line. So that's how a queue works. All right. So here's your stack functions, push, pop, peak. Make sure you know what those are, know what each one does, understand the difference between peak and pop. Pop actually removes something, peak does not. All right, then we made the jump from linear linked data structures to non-linear linked data structures, where we have nodes with potentially more than one child, right? With 0 or more children, where before this, everything was exactly one child. Well, I guess 0 or one child. So the end of a linked list doesn't have a next node, but at most you have one. Binary trees, at most you have 2. N-ary trees, at most you have n children. All right, so understand how binary trees are organized. Oh, we should definitely have a merge sort question on the exam. Just write merge sort.
In a different language.
Oh, it doesn't matter. But you pick like an obscure language,
Right.
or a language that doesn't exist.
Right, Scheme.
Scheme's merge sort is actually pretty easy. The Scheme's everything's recursive in Scheme.
Yeah, I figured.
Um,
Probably a pain for us.
I would say, you should definitely understand merge sort. I probably wouldn't have you write merge sort, but it's possible I might give you a short array and say, show me the steps of performing merge sort on this. That would be a fair question to ask. So at the very least, you should understand how merge sort, what the algorithm is, and be able to, if I gave you 4 numbers like this, you should be able to show me that it divides up in half, divides up until you have 2 1 lists, pops back up, merges those guys together, pops back up, makes the next call. Not write the code for it, but be able to show me that algorithm. Walk through the steps. See how we're doing back over here. We'll just do a normal play. Here, we'll let that keep going. My backup plan for that is if for some reason we can't get the network working, I'll just copy the JSON in and we'll just parse it as if we retrieved it. That way we can do the loading it in the linked list stuff. Definitely understand pass by value versus pass by reference. That's something we've been covering since last semester, but really, really important. Arrays and all of our objects are passed by reference. We get a memory address to them, where primitive types are passed by value. Know what recursion is. It would be fair game to write a recursive function. I would make it an easy recursive function, but you should be able to define functions in terms of themselves. Understand how binary trees work and how something gets added to the binary tree. So for instance, if I give you this could be in one of the non-programming questions. If I give you a list of numbers and I say add these numbers, show me the tree that would result in adding these numbers to the tree in this order. Something like that. And I would ask you to draw that tree for me, what it would ultimately look like. So understanding that things that are less than or equal to go to the left of something, things that are greater than go to the right of something. Right? And remember, the order in which we add stuff to a tree does dictate what the tree ultimately looks like, right? If I have the same 10 numbers, if I add them in different orders, I might end up with 10 different trees. Potentially. Because that very first value is going to be the root node, and everything's going to be relative to where that is in terms of less than or greater than.
Do you know the pre-order and post-order? Or...
Definitely.
Okay.
Yep. So, again, if I gave you a tree, and then I said, visit this, show me the, visiting this tree in pre-order, post-order, and in order, and I asked you to tell me what the output would be. So I probably wouldn't ask you to write the code for that. Not that I couldn't, but I just probably won't. You should be able to tell me what it means to visit an in-order, pre-order, and post-order and give me the output. And I could also promise you, at least this past year, that exact question was on the senior seminar competency exam. Walking a tree, pre-order, post-order, in-order. That should be 3 points. And it was missed more than it should have been missed on that test. All right, so we kind of upgraded our mentality of a binary tree being a tree of trees. So you'll at least have to know that at the theoretical level. It's possible I'll ask you to write something related to a binary tree, or have a binary tree that maybe follows a little bit different set of rules than the traditional binary tree. Something like that, so it's binary tree-esque. I would explain some algorithm that you needed to follow. Maybe everything that is evenly divisible by the top level node goes to the left of it. Everything that's not goes to the right of it, something like that. I don't know what kind of monstrous data structure it ultimately produces and how useful it might be, but technically it would be something you should be able to do. Here's that tree traversal stuff. Will definitely be on the exam. I could almost guarantee this will be represented one way or another. If I ask a question at the traveling salesman problem, it'll just be a very high level one. I don't think I'll be able to fit it on there because we didn't get into graph theory very much. But Dr. Locklear definitely talks about this problem in the 490 class. Definitely JSON. Understand what JSON is, be able to read JSON, be able to write JSON. I might give you an object and tell you to give me the JSON equivalent of this object. So perhaps I give you an array of person objects or something like that and ask you to write the JSON that represents that array. So you'd have a collection of JSON objects where each object is a collection of the name value pairs, or each JSON object is a collection of name value pairs for that object. So be able to read and be able to write JSON. Yeah, I probably wouldn't take off for like whether or not you put a double quote in there or didn't need a double quote in the JSON, but you should definitely understand the structure of JSON. The curly brace, the commas, the the colon, for the name value pair stuff, that kind of stuff. You know what we forgot to take a picture of yesterday is that inflatable colon at the tech conference we went to yesterday.
I was hoping it would be there on the way back.
Yeah, I don't. At least I didn't see it.
It wasn't.
What was that in there?
Well, they must have had like some kind of health fair or something like that where they were presenting something.
It's like there's always depressed people around this giant.
Yeah, they had a giant inflatable colon that had like, you could walk inside of it and see like different types of, digestive issues, Crohn's and stuff like that. They were educating people, but it was entertaining. I just can't believe we didn't take a picture with that. It's a shame.
We saw it when we passed.
Yeah, we just walked right past. Hey. All right, so definitely understand JSON. Possible chance I might ask something about its relationship to XML, but I doubt it. I'll probably want you to do something applied with JSON. Write it, read it, possibly parse it. We've looked at our code that was we worked with this week. The parsing it part probably wouldn't be a real heavy part of the exam, but it would be fair for me to give you some JSON and tell you to write the necessary code to pull out the address or something like that. Understand what an API is. Certainly understand this concept of RESTful APIs. I'm probably not going to ask you historic questions like, the SOAP standard and, that kind of stuff, but know what it means for an API to be a RESTful API and that it's implemented on top of the HTTP protocol. Know what the HTTP protocol is. Get, post, put, delete. Firebase still a fair game. I don't know. There could be a question on the exam related to like the synchronous versus asynchronous calls, where actually we didn't do any synchronous calls. All network calls in Android are done asynchronously, and all network calls with Firebase are done asynchronously, which means that, what does it mean for a call to be asynchronous? Yeah. Runs in the background effectively, but its implementation is it's running in separate threads, right? Okay, so if something is asynchronous, it runs in the background and our application can continue on. All right, and that's why with Firebase we had to set up a listener. Let us know once you have your answer, that type of thing, right? Whereas if we go back here, I'll go ahead and run this again and see if we have a better result this time through. In fact, just for completeness, let me kill off my emulator here. But right here, we're actually experiencing a synchronous call. This line right here isn't completing because con.getInputStream is blocking. It's trying to open up the input stream related to that network connection, and it's not able to get past it. So our application is pausing or blocking on this line, where if we had done that inside of a thread, it would be running asynchronously behind the scenes and let our application continue running. That make some sense? Oh, I'm betting it is this emulator here because this guy isn't wanting to die. There you go. So let's give that one more college try here. Which one do we want to do? Pixel 2 API? Yeah, let's go that route. That might have been our problem all along. That our emulator did not want to play nice. Yep, it was. It was our emulator. So there's our output there. So let's finish. Now that we know we have a working deal over here, let's just finish talking about the exam, and we'll swing back through and finish this. This is only going to take a couple minutes. I should have checked that first. Sometimes that emulator doesn't survive multiple laptop lid closings and stuff like that. And then flip with that is I also am flipping between Android projects for a couple of my different classes. So then you're switching projects really running on that same emulator. Yeah, it was just in a bad state. So do understand Firebase. Sometimes it's hard to ask Firebase type questions on an exam. One thing I do want to kind of emphasize, but I might have trouble coming up with if I can come up with a way of asking it that I think is fair, I'll do it. But it's a high priority for me anyways. And for those of you who went to the senior seminar presentations last night, one thing you kind of heard several times is people were saying that they struggle with reading data from Firebase. Okay, and part of that, and we have a little bit of the advantage in here, and we're going to have even more. The next group of students will have more of an advantage because we're going to start introducing Firebase in 250. It was introduced to you in 300. Last year, 300 didn't even have it in here. All right, so we're splitting some of the database programming between the database class and the programming classes. But punchline is that being able to get data from a database into your application, and right now we're doing it with Yelp. Whether it came from a database or whether it came from Yelp, being able to bring data from other places into our app and then being able to do something with that data is a really important skill. Okay, so whether or not I'm going to be able to adequately test you on, working with a data snapshot from Firebase. We had our listener and we brought in information from the about our basketball players. Whether I'll really be able to test you on that might be somewhat difficult in an exam situation, but that's something you're going to want to make sure you continue to be familiar with and practice with, and hopefully you're maybe gaining an appreciation now. If you go back and you look at those data snapshots, you'll see that all they are is JSON. Just instead of creating a JSON object like we've been creating recently, like we did here, Firebase gives us something called a data snapshot, which is their version of a JSON object. Does that make sense? So, it's been kind of hiding in plain sight since early in the semester is the punchline here. But hopefully you recognize these are several of our seniors who are starting to graduate who admittedly did not benefit from having Firebase in their earlier classes, and they're struggling with it as seniors. I can think of at least 2 projects where they said that was the part that they struggled with the most, is being able to read from the database. So if that's not a skill that you thought you had or something you struggle with, that would be something to keep working on, because I will continue as you have more classes with me. The 450 class will probably do some Firebase stuff in or some database stuff in at the very least. But we'll continue to have you bringing data in from other places other than locally on your machine and processing that. And a lot of that's going to be in JSON format. Okay, so again, what does it mean for an API to be RESTful? I probably wouldn't ask deep depth questions about this Yelp API or something like that, but there could be kind of a catch-all API question that hits the RESTful API and HTTP and authorization. And you joined us.
I did.
Oversleep? Better excuse?
We'll go with
long breakfast?
No breakfast. It was a partial oversleep, but it was more me didn't want to get out of bed because.
This was a choice?
Because I felt like a failure in life. I wanted to stay there and cry for a little bit.
Did you cry?
There were a couple of tears.
Did you send me a picture?
No.
Then it didn't happen. All right, so it would be fair game for me to ask you questions about APIs in general. I probably wouldn't go into great depths about Yelp specifically, but that whole concept of before a third party might give you their data, they might want you to authorize with them. So that could be somewhat of fair game. I wouldn't really focus much on the code aspect of that as much as the kind of the academic understanding of why do we talk to APIs, what are modern APIs kind of look like, what format do they give us the data in, how do we use that format, that kind of stuff. Kind of makes some sense? I want that to be a competency. You can at any point in time go back and grab the 5 lines of code that we use to open up the connection. I don't want you to memorize that for some exam. Question 1 through 3 on the exam. Write line 1 of opening up an API. I should totally do that. All right.
Write the API key from memory.
That is going on the exam. 95%, 95 points. Then like 9 more questions, each worth whatever, let's do 90. Let's do 91 points. 9 more questions, each worth a point. Yeah,
Are those our individual API keys?
that's all of them.
Oh, all the API keys available.
Well, no. All the API keys of all of us in class.
Okay.
So it's kind of like similar to our CS get together when we have that like thing at the beginning when you have to go and find out who has a shoe size. The same as you're gonna have to go and talk and exchange API keys and it's kind of, during the exam you can have a buddy system. All right. So along those lines, also understand what a tool like Postman's for. What problem that solves. It allows us to kind of figure out the question we want to ask first and make sure we get all the right parameters and authorization stuff correct before we bring it into our code and start just saying, now I want to work with the data. Because you can spend hours and hours and hours in your code wondering why something's not working and it's some stupid HTTP mistake that you made that would have been revealed if you just used Postman. But because you typed it directly into code first, this is kind of our API equivalent of drawing pictures. Do it in Postman first. Get your request correct. Make sure it's giving you the JSON data you were expecting. Then once you're confident with that, you can bring it into your code and start making actual data calls with the intention of processing them in your application. All right, so understand the purpose of a tool like Postman. There's other tools like Postman, but this, as far as I know, this is like the super famous one. I can't even think about another one. I think Postman's been around for a while, and it's the one everyone uses. And it's not really solving any sort of crazy problem. It's just an implementation of an HTTP client. Saying, hey, you don't want to use your web browser to fake this? By the way, here's a web browser. We're not going to show you pretty pictures, but you can make all the four different kinds of HTTP calls. Thumbs up. All right. Okay. Understand JSON, the collection of JSON arrays, JSON objects, what a JSON object is, that kind of stuff. Be fair game to do the thing where Android doesn't allow you to have network calls on the main thread. I probably wouldn't ask that in the exam, but just something to store in the back of your head, because the next time you go to try to make a network call in Android, it might yell at you and say you're not allowed to make a network call on the main thread, and you'll have to create your own thread unless you're using a third-party API like when we used Firebase. I guarantee you when you made that call and we said listen for changes to the database, that was spawning off a thread. It's an asynchronous call, so even though we didn't write the thread, they wrote the thread and we just called upon that function that creates the thread. You should understand the concept of threads, but that would be more of a, in here we care more about a thread as it equates to asynchronous communication, stuff happening in the background. This would be a pretty big topic in an operating systems class, dealing with how they're scheduled and that kind of stuff. So I won't ask a question about, like, tell me about threads, other than I might use the word thread in a question or something, and I would expect you know what I'm talking about when I say thread. Make sense? Yes. Like, what size do you want that shirt? Same thing with interfaces. We've talked quite a bit this semester. We kind of bookended the class. We had serializable early on in the class. We had runnable more recently, where an interface differentiates itself from a class from the perspective that it dictates what a class must do as opposed to what a class gets. When we extend another class, okay, so when we wrote our Yelp API class and we extended thread, we got all of Thread's magic. And then we further differentiated ourselves by overriding one of his methods. Make sense? Whereas an interface says, look, we're not giving you any implementation. We're just saying this is the stuff you have to do if you say you're one of us. Okay? So if you wanted to implement the basketball playerable, let's say that's a thing. Yeah, let's just go with it since a bull, most of our interfaces are called a bull. Chances are if you're going to be a basketball player, you need to be able to shoot free throws, at least academically. Some players are better at shooting free throws than others, but you should have a method written called shoot free throw as a basketball player, right? All right, so otherwise you can't call yourself a basketball player if you can't functionally try to shoot a free throw. Okay, same thing, dribble. You should be able to dribble as a basketball player. You can't call yourself a basketball player if you can't dribble. You don't have to be the best dribbler. You're definitely not a basketball player if you're not dribbling at all. Just running around, carrying the ball. That's how Mr. Gonzalez plays basketball. He pops it. Everybody gets upset and he laughs. So that's kind of the difference between interface and interfaces and classes. We talked about them more recently because we didn't really bring the term interface into heavy use early on when we talked about serializable, because we were looking at serializable as more of like the magic keyword that was used to make a object work with Firebase. But now we've kind of determined, now that we've added in this idea of working with an API and seeing how that's actually kind of, we're seeing under the hood a little bit of what Firebase was doing, that serializable is really the means by which Java allows us to have a class, an object, serialize into JSON. Similarly, it can deserialize or marshal back into an object from JSON. And that happens magically through this serializable interface, which then Java's internal system says, oh yeah, I know how to make an object out of JSON. Kind of makes some sense. So that's what serializable ultimately is. Serializable is also a little bit hard to teach interfaces from, since it actually doesn't require you to write any functions. From our perspective, it really required us to do two things: make all our fields public, well, all our fields we wanted to be included in the JSON public, and write a no argument constructor. That was it. So it's a little bit hard to teach the larger, because serializable is kind of like the string of interfaces, where strings are technically objects, but they act like primitives most of the time. Serializable is kind of like that because it's kind of internally handled by Java. They do the magic of like, you mark this guy as serializable, you just set the things as public and give me a no argument constructor and we'll take care of the rest magically. So kind of like with a string, you could say string s is equal to hello, where every other object you ever created, you have to say object type name equals new, called to the constructor. You can do that with strings, but you don't have to do that with strings. So they're giving you this like special syntactic sugar for strings. Runnable is more of your traditional interface, where we say, look, if you're going to implement runnable, you better give us a public void run function. We don't care what you put in there, but you got to have one. Make sense? All right, so that's what an interface does. It kind of polices us and says you have to, if you want to be a member of something that is runnable in this case, you have to have that method, because anybody who's going to interact with you as something that's runnable is going to rely on you having that ability. All right. And then maybe that connection, I mean, it would be fair game for me to talk about the Java thread class from the perspective of that start function, if for threads, has some magic sauce associated with it, where it does all the magic operating system stuff of actually creating a new thread. And then it calls the run method to do whatever that thread's supposed to actually accomplish in the background. That makes sense? So that's how, so if we look at the thread class would implement runnable, which means it has a run method that by default does nothing. So when we extend thread, we get all of thread's magic plus his run method that does nothing. And then we would choose to override that run method and put our something in there, whatever we decide we want that thread to actually accomplish. That makes some sense? Okay. Universal. You should know what a URL is. I don't know how I would ask it. I probably won't ask anything about that. Same thing. You should know about exception handling. I probably wouldn't test over it. But it's Java's way of gracefully handling errors. It's kind of a weird thing to test over. You know, it's a hard thing to test over. All right, so that's the stuff since the midterm. Let me just jump back to the beginning and see if something stands out as something that I really want to focus on. Obviously, you need to be familiar with the this keyword. It should be ingrained in your soul by now. You should also be familiar with singletons and the other design patterns. So the MVC, model view controller, as well as observer design pattern. I think the observer design pattern was on the midterm and was pretty heavily missed. And I asked something about singletons versus observers. I think, if I remember correctly, that was something that a lot of people didn't have the difference between. So make sure you understand our different design patterns and the problems they attempt to solve. Definitely understand array adapters. You know, that's something you had to bring back into the fold in this assignment right here that we just wrote. So array adapters are, you know, the means by which we adapt an array to work with a list view. Understand the super keyword. This is our ability to call up to our parent when we use inheritance, when we extend something. So if we have our Yelp API class, which extends thread, super dot is talking to the thread class. And we can kind of show that right here. If I come up here to the beginning of run right here, and I say super dot run, there's the example that the thread class, which implements runnable, has his own run method. So right there, I'm calling the threads run method, which does nothing. Okay. Also remember, if you want to have a constructor, if you want to call upon your parent's constructor, it must happen first in your code. The very first thing in your code needs to use your parent to do some initial construction, if you choose to do that, and then you can further differentiate yourself. Probably wouldn't ask you to write that, but you should be able to read it. If I give you some code that happens to show you some inheritance stuff, and you know it happens to build an object in terms of its parent first, and then differentiate itself, you should know what that means.
Do you have an idea of what we will have to write?
It would be more of like write a function that does this, write a function that does that. There'll probably be at least something with string manipulation. You know, probably in the ballpark. It probably wouldn't be this exact one, but like, you know, reverse a string, remove vowels, you know, that kind of stuff. Doing something with arrays. Taking a linked list in as a parameter and doing something with that linked list, taking a stack in as a parameter and doing something with a stack, taking a binary tree in as a parameter and doing something with that, searching for a value in the binary tree, something along those lines. So your typical write a function that does this, write a function that does that, kind of in that ballpark of things. I would also be surprised if I don't ask you to write a class of some sort, you know, be able to write an object. I might choose to make it a little bit more complex than it was on the midterm. Maybe he has a collection of something like a linked list or something like that as part of his definition, but you know, have the appropriate setters and getters and a constructor, that kind of stuff. So that should be something we're pretty accustomed to now, where we like, oh, we need an object that does this. We'll just create that object real quick, and now we have a nice little container that carries those guys around. All right, so you should be able to create those types of things. Custom array adapter, again, maybe kind of hard to test on. It's one of those things that's a little bit tedious to do in code, but you know, the idea that we are overriding the get view function is effectively what we're doing with a custom array adapter. We're saying, hey, the default array adapter only knows how to show a string, so what am I going to do here? I'm going to teach you how to show two strings on two different text views instead of one string on one text view, something like that. So you have to re-implement the get view function for array adapters in order to give yourself a special version of one of those. So like I said, I probably wouldn't programmatically ask you to do anything with that. It might be fair game for a non-programming question to be like, what function needs to be overridden for a custom array adapter and why, something like that. You need to override the get view method because you have to teach your collection type, the type you're trying to show, how to show itself in a custom designed row or something like that. I won't ask questions about other databases. That's 430 stuff. I was really kind of seeing where does Firebase fit into the world. Okay, so I won't ask about Heroku. I won't ask about the origins of Firebase. You don't need to know. I mean, you should know that it's a NoSQL database, a real-time database that works with JSON, but I'm not going to ask you those questions on the exam. That was more just saying, hey, here's a tool you bought from Home Depot. You look at the back of it, it says, here's all my features, and now you just take it home and use it. All right, so I'm going to care more about the utilization of Firebase in here. Nothing about this stuff. Same thing with cloud computing, platform as a service, infrastructure as a service, all good things, all things that you should pack away somewhere in your mind for when you start working with cloud APIs and things like that in future classes and in industry, but not necessarily related to the core concepts of this course. It was more about where does Firebase fit in our zoo of technology that's out there. Yeah, so here is our original interface discussion related to serializable. And we just talked a few minutes ago how it's kind of hard to teach interface from that perspective because they don't actually make you write a function. They just kind of say, follow these rules. So it's kind of a special case type dude. You should know what this push function does for Firebase. What does push do for Firebase? When I say something.child.push, what does that push do?
It generates like a random key.
Yeah. So it gives me like a unique ID for that endpoint. So if I want to have, a whole bunch of, I'm adding user keywords or something like that. Maybe I would have .child users, .child mic, .push one keyword, .push another keyword, .push another keyword. So each of those keywords has like a unique identifier associated with it. So push gives us a way of making similar entries uniquely definable or uniquely readable because push gives us a unique key. So super keyword. There's your observer design pattern. Synchronous versus asynchronous. You should know the difference between them. I don't anticipate asking the specific question of what's the difference. I want to say maybe that was on the midterm. I don't remember. But asynchronous should be a pretty important term to you in computer science because it's kind of our go-to move of having a lot of stuff happening at once without seeming to happen at once. Static versus non-static context. Again, this is an important concept related to static versus non-static methods, whether it's a class method or an instance method. Depending on my mood, I could see throwing a question like that, a throwback question on there about, how are class methods defined? How are instance methods defined? How are class methods called? How are instance methods called? That's something that should be automatic to you now, but historically has not been automatic to you. So that's just about being able to read Java documentation and instantly knowing how to call something, just by the way it's defined. This is our data snapshot thing. It's basically a wrapper for Firebase's JSON. Probably will not have you directly work with it on the exam. You should know how to work with these, but sometimes that's one of those things you kind of have to mess with a little bit till you get the right stuff out of it. So it might not be real compatible with an exam question. Be able to rate an object. Know the problems with arrays versus linked lists, but it was really a midterm question. At this point, we should appreciate that linked lists are flexible, arrays are fast. So I probably would not ask you this question directly. I have plenty of other things to ask. Yeah, so I think that covers all the stuff that the exam might cover. So questions about the exam? All right, so let's dive back over to this real quick. I'll go ahead and run this through the debugger. That way we can see that we're getting the name and phone correctly. We're getting the display phone number here. All right, I'll just take this out or run it to the next guy here. Look, we made it. All right, so I'll just flip past name and phone. So here's name is the Cheel. Here's the phone number. That looks, oh, can I, Ninja, I thought I could zoom here. Oh, I can only zoom in Logcat, but whatever. Here's name and phone number. Looks like I have the right stuff. Zip to the next one. Bounce past those two. We have Cafe 1505. Here's their phone number. So we seem like we have the right stuff. All right. And we're just supposed to show the name and the phone number on that next screen. All right, I'm going to cheat a little bit for time, where I'm going to actually use a default ArrayAdapter to pull this off. I'll show you something that I think I told you had to do with a custom ArrayAdapter if you were showing them both, but you could technically build a string and do a \n. So we'll just do that just for the sake of time. We've done the custom ArrayAdapter before, so that's just something you would have gone back to old code and looked at. So I'll create a new empty activity, and we'll call this guy restaurant activity. Okay, and it's asking me to add it to my Git thing, so I'll say add. All right, we'll go and design this guy real quick. I'm going to make this pretty quick and dirty. All right, so I'll go ahead and change this guy to my vertical linear layout. Convert view, linear layout. We're going to make him vertically oriented. We'll throw a text view in here. We'll have this guy say restaurant list, like that. Give it a little bit bigger thing there. Then I'm going to go ahead and go to legacy. We'll go to list view. We'll drag our list view out here. We're going to give this guy a name. So we're going to call this guy restaurant LV. Okay. And we're going to go ahead and bring these guys up into, do I have a core yet? I'll just build a core real quick. That'll be quick and dirty. So I'll create a Java class. We'll call this guy core. We're going to put I'll put a public static linked list. I gotta do this quick. So we're going to say a linked list of strings. We'll call this the restaurant strings. And then inside of my Yelp API, where I'm filling this guy, I'm going to go ahead and add each of these to my restaurant strings. So I'll say core.therestaurantstrings.add dot add, and I'm going to add the string name concatenated with \n concatenated with phone. Oh, this needs to be a, I could do it as a char or a string. That'll work. All right, \n is a carriage return. Okay. So after I'm done with this, on our main activity screen, we need to have a button that takes us to our restaurant activity. Where's my main? There he is. So we'll throw a button on here. Just say go. We'll say LOL. Inside of main activity, I'll go ahead and build my public void on LOL button clicked UV. And what this guy's going to do is he's going to create an intent I is equal to a new intent from this context to restaurant activity.class. And then we'll say this dot start activity I. That'll take us to that next screen. Inside of our restaurant activity, I'll go ahead and grab my list view. So I'm going to say list view RLV is equal to r dot, or this dot find view r dot id dot restaurant lv. All right, and then we'll say rlv dot set adapter to a new. Actually, we'll build our array adapter on a separate line. So we'll say array adapter of type string AA is equal to a new array adapter of type string, and this guy takes in a context. It takes in a simple row, and what is it called? Is it r.android or is it android dot? I just want to show you something real quick. Android simple list row. Android.r layout. So there's actually a simple list item thing already built into Android, so you don't actually even need to create one. So I'll just show that to you. It's just something with a single text view in it. So it's already there for you. And then my list is going to be core dot, what do I call it, the restaurant strings. And then we'll say rlv dot set adapter to be AA. Okay. And then in main activity, I need to tell this guy to have his onClick call that function. And that function will launch our restaurant activity guy, which grabs our list view, creates our array adapter, and displays all of those things. All right, so there's that. We'll go ahead and hit LOL, and there's all my restaurants. That makes sense? Now, in our last 4 minutes here, let me show you kind of a little a trick. You've seen the syntax before, but let me just connect one last dot for you from earlier this semester. Remember when you created the on value listener for, or what, on item click listener for clicking on rows in a list view? And then we also had on value change listener for Firebase. We had this kind of weird syntax for it. let me show you what you can do here in, we probably won't have time to actually implement it out, but let's say you wanted to have a custom array adapter that was without having to write your own custom array adapter. What you can say is array adapter, and we're going to call this guy, we don't really have, well, here, I'm just going to throw something other than string in there for now. We aren't creating instances of these, but it should work. Array adapter AA2 is equal to new array adapter of type main activity, and we're going to pass this guy this. We're going to pass this guy our simple layout. Let's just say android.r.layout.simple list item 1, whatever. We're going to pass him a linked list of main activities, even though we didn't build one. We'll just say here's a new linked list of main activities. All right. But now, instead of putting a semicolon there and finishing it, I'm going to put an opening curly brace there, and I'm going to start writing get view. Actually, I put the wrong thing there. So I can override get view inline. I could write my own version of get view in here and teach it how to. So assuming we didn't use, let's say we wrote our own layout right here. It had two lists, two text views. We had two text views in it, and let's say it was r.myCustomRow, r.layout.myCustomRow, something like that. I could go ahead and just write my code right in here for teaching it how to get a main activity from position in my collection and show it in that custom row type, rather than having my own custom array adapter that extends array adapter and building all this stuff. So you could do it in line like this. This is like an alternative to what you maybe previously did by having it in its own class. I wouldn't call this necessarily better. If it's a one-off, if you're only going to have a special list for this one type of object, this probably makes the most sense rather than cluttering up with one more class over here. But a lot of times you might have an array adapter that does something specific that you use 3 or 4 times throughout your entire application. In that case, you'd probably write it once inside of a class and then use that in multiple places. That makes sense? But what this is right here, this has little to do with array adapters and more to do with the ability to override an aspect of a class inline without creating a child of that class. Make some sense? Okay. Won't test you on it, but this is more just pack it away in your head that if you only have one method you want to override for something, you can technically pull it off. Questions, comments, concerns, bribes? All right, so hopefully I'll see most of you tonight at the senior seminar presentations from 5 till 10 p.m., whatever it was. Otherwise, I will see you on, it was Tuesday at 10 a.m. All right, I will see you then. And I'll take this last piece of code. Well, here, I'll comment this piece out just so you have kind of the structure for it. But I'll leave this as just my working and commit it.
Yeah, I'll let you. That's all good.
I've created so many classes for that thing to show up.
Yeah, so wasn't this easy? Does it seem easier now?
I need to review that thing though, like the list view of how like you put things together.
I mean, I'm just about the specifications and requirements. I was